If you're watching this video, you likely have some amount of familiarity with square roots and how they work to some extent. Something you may be aware of then is that we can run into problems when we try to square root a negative number. For example, if you were to go to your calculator and try and put in the square root of any negative number you could think of, it's going to give you some sort of error message. As a way of getting around our issues with square rooting negative numbers, we have the imaginary number I, which you can see on your screen here. I, the letter I, is specifically meant to represent or to be equal to the square root of negative 1. The usefulness of that is now, let's say we want to do the square root of negative 4. Well, if you go to your calculator and put in the square root of negative 4, you're not going to get anything out of that. It's just going to be an error. But if we use this imaginary number I, what we could do is split up the square root of negative 4 into the square root of negative 1 and the square root of positive 4. And so since we have stated that the square root of negative 1 is I, and we know that the square root of positive 4 is 2, or if you don't know, your calculator can tell you that, right? You can just plug in the square root of positive 4. Now we could say that the square root of negative 4 is simply equal to 2i. And that's generally how all square rooting of negative numbers is going to go. You're basically just going to take the square root of the positive version of that number, and then you will also have an I with it. With the introduction of the imaginary number I, we now have the potential for what we call complex numbers to be created. Complex numbers simply just means a situation where we have both a real part and an imaginary part. If that scenario comes about, where we have a real number as well as an imaginary number, the real part has to come first. This may be a little odd, because pretty much everywhere else in algebra, you are used to putting letters first. Meaning if you had a 2x and a 3, you wouldn't write it as 3 plus 2x. You would write it as 2x plus 3. But while that is the correct way to write pretty much any variable, right? You do the same thing with 2y plus 3, 2z. If it is an I, it would not be 2i plus 3. It would be 3 plus 2i. That is the somewhat tricky part of dealing with imaginaries and complexes. If you have a complex number, you have to get used to putting the real number first and then the imaginary number second. Let's look at a few examples of how we could end up with complex numbers. So with our first one here, we've got 3 plus the square root of negative 25. Well, our first step certainly needs to be simplifying the square root of negative 25 to see what we're even dealing with there. If we look at the square root of negative 25, as it stands right now, we have a problem because square rooting a negative number. But as we already discussed in this lesson, we can use our first step to split this up into the square root of negative 1 and the square root of positive 25. Now, we know the square root of negative 1 is just I, and we can actually do the square root of positive 25, which we know to simply be 5. So we can rewrite this problem as 3 plus 5i. You do want to take an extra look at this, and since we have a real part and an imaginary part, make sure it is in the correct order. The real part of 3 is first. The imaginary part of 5i is second. So we have this in the correct order. This is in standard form. Looking at the second example, we have the square root of negative 27. It's all by itself, so no matter what, our first step is to try and simplify this out. Again, just like any other time we're square rooting a negative number, our first step is to split this up into the square root of negative 1 and the square root of the positive version, 27. Now this time, we do not have a number that square roots perfectly. So instead what we're going to have to do is simplify this radical by breaking it down. Remember, we did already have a video about this, so if you have not already looked at the video for simplifying radicals, I would recommend taking a look at that. We know 27 breaks down to 3 and 9, and then 9 breaks down into 3 and 3. We would be looking for pairs because this is a square root, so I see a pair of 3's and one lonely 3, which means the pair counts for a single 3 outside the radical. We also have an I representing the square root of -1, and then that lonely 3 that didn't have a pair has to stay inside the square root. Recognize that I should always be written outside the square root. Reason for that being, I represents the square root of -1, so if you put I inside a square root, it'd be a square root inside a square root. So I should be outside. Now this last example has something we haven't encountered yet in this lesson. It has an I squared. So if we think about this, we have already established that I represents the square root of -1. We know from past lessons that a square root and a square effectively cancel each other out, right? They are inverses of each other. Square rooting is the inverse of squaring, squaring is the inverse of square rooting. So if I represents the square root of -1, then I squared would mean we are taking the square root of -1 and squaring it. And so the square root and the square would effectively cancel each other out, meaning I squared would be equal to just -1. If that makes sense, we can use that new knowledge to help us solve this last example. First step then would be to change I squared to -1. So we'd have -9i, just rewriting that, plus 8, but instead of times I squared, it is now times -1. We know 8 times -1 would be -8, so we now have -9i minus 8. We are done simplifying here, but this is not a final answer. Remember, standard form says we have to have the real part come first. So our final answer would be to rewrite this as -8 minus 9i. That would be standard form, the correct order for our final answer.